Hey, and welcome to another episode of Learning Rust with Gadoxide. It's 1 day past, I think. Oh yeah, welcome Sydney. Nice to have you on the show. Yeah, we didn't have the show yesterday because we're super busy releasing Cargo Smart Release, which can now do changelogs. So in case you didn't know that yet, I want to try it out. Cargo install, Cargo Smart Release. Shameless plug for the people who watch. Last session we talked about lifetimes quite a bit actually, and I think the only thing that might still be open is like what happens when you borrow something and you try to move you try to move the original that it's borrowed from while the borrow is active. Like,
I would think Rust wouldn't allow that, right? I mean, it seems like the borrow checker should say, no, that's not good.
Yeah, should. But let's put it to the test real quick. This should compile. Also resize our faces here. Now we're on the bottom right. Okay, that works. And now this hello is actually borrowed to X. So here's a good spot to try to do something with hello. I could explicitly drop it, for example. And then we already see that something doesn't work. Ah yeah. Borrow of hello occurs here. Move out of hello occurs here, even though the borrow is later used there. Which is interesting because it's not really hello that is used, right? It's world that is used. But it's part of the X now and it just doesn't like it. So in theory, that's okay. That's what I'm saying.
True. But isn't it's probably checking that using lifetimes, right? And maybe it can detect that the shortest lifetime is shorter than what is being seen here.
Yeah, I mean, it all makes sense to some extent. It's probably just the safest to reject that because now we drop something that is still here and it's there, even though if it would do usage analysis completely, it would see that, well, hello is not used, so why am I upset about that? And of course, you can always work around that by doing that differently. So usually that's not a bummer, and by doing it differently so that you respect lifetimes, usually the code is more readable. So it's not even a bad thing that Rust is not able to do this perfect analysis. I also did not even commit that session 4, essentially. That is the state. Sloppy work of mine. Yeah, that would probably conclude lifetimes for us. I've talked about structs, the different kinds of structs, and that's pretty much it. We also kind of silently use the drop trait here that gets called when something goes out of scope. And is dropped for that matter. And now we have quickly used the drop function that apparently drops things. Can you imagine how drop is implemented? Like, is it magical? Or is it something you can do yourself?
I'm not sure. I mean, it probably just either it frees the memory completely or it just erases the pointer to the data. I'm not sure.
So
But
complicated thinking. Pointers, memory. That's the implementation, and of course you can implement that yourself. Takes any t, but wants to own it and does nothing. Hence, it drops it.
That works.
Yeah, see? It's very nice. Sure, in the standard library, there's always more attributes here because it's a standard library. And yeah, it's a bit more complex that for that matter, but in theory, it's easy. All right, then let's start something new because ownership and borrowing is done, and I think the next big topic will be options and results. I think that's the next level. There's no way around it. It's everywhere. So what do we have here? We have ownership and borrowing. We have a cargo toml top level file with a bunch of members. So this is a workspace, which means we can have multiple crates that are somehow related to each other, but have cargo. Have cargo compile. I'm not in Tmux here, so that Tmux stuff won't work. Let's use the mouse. So cargo will put its build results into one folder, splitting up and reuse dependencies that are shared among the crates, so that builds faster. This is why, well, if you have lots of crates that are related to each other, then definitely put it into the same repo and into one workspace. And now for us it doesn't really matter, I think, but workspaces are nice, especially if you have cargo smart release. Really, you want that if you want to release stuff. Shameless plug again, but it's so good. I like it. So now cargo new, we create a binary and we do options and results. I think I should spell that out. Create that, and it now tells you that it's part of a workspace, but the workspace doesn't know about it, and also the package doesn't know about it. And cargo doesn't do that for you, so it gives you a lot of text here to tell you how to fix it. Yeah, I wish the future cargo would just drop you into some sort of selection, so you can just select interactively while you're in a terminal, right? Just like many tools do these days, and just ask you, what do you want to do? Want to ignore that or want to add it to the workspace? But now I have, okay, I have to use the mouse. Let's see, options and results, and just put it here. And now everything should be happy. So can I check this? Does it work? Does it compile? It looks like it. Cool. Add new session binary. Okay. Now IntelliJ should pick that up and allow us to work with it just like before. I should be able to run it. Run options and results. Yeah. I'm all for the terminal, but running things from IntelliJ has the advantage that you can easily click to errors that show up, and then it actually jumps right there. It just makes it easier to fix things immediately.
That's nice.
So yeah, overall it's just too comfortable to not use, at least for me. But yeah, I want to get off it, but it's too good. It's like what many addicts say, I guess. I know it's wrong, but it's too good. Okay, now options. Let's start with Booleans. I really like what you can do with Booleans in Rust. So let x be true and let y be false. And that's Booleans are nice, right? They're so binary. It's either that or it's that. And that can be useful, but you know what would even be more useful? And then this is where you say, no, tell me.
Please tell me.
Oh, glad you asked. So what's even more useful is if you could have some actual value carried if something is there or true, and have just nothing there if it's false. So kind of as an upgrade to a Boolean, you can have options. So let's say x is now some value. whereas y is none. Interesting. That already doesn't work. Let's go with the working one. Okay. Let's see if that compiles. That compiles. And once again, I think we don't want to hear about unused items and that code. Just let us be. Okay, nice. Okay. So that seems easy. Also strange syntax, like what type is this now?
It looks like a tuple struct.
Yeah, that's true. It looks like a tuple. Interesting. Somehow I get blind to that. Like to me, obviously it's an option. It parses as such for me, but yes, it's much like a tuple struct. Maybe it is even a tuple struct, kind of. Let's just go there. Let's just jump to some. I mean, it's kind of weird too, because I would expect something like option to be here, but it's not. Let's jump there and see what we have. Once again, a lot of crazy stuff in the standard library. But if we just ignore the annotations, what we have is an enum. And we have generics kind of, but the simple kind of generics. So I guess it's okay to see it now. We saw that before with lifetimes, remember? Same syntax, single lifetime in the struct.
Yeah, it makes sense.
Yeah, makes sense. So lifetimes are really just something that is giving you a set of types, one for each lifetime, one specific type for each lifetime, whereas this gives us one option for each possible invocation of t, or instantiation of t, you could say. And the syntax here is such that you say you want an enum, and then you just have the capitalized variant. This is a variant. That's the name for these things. And one variant, it looks much like a unit struct, like the one we did initially. So it doesn't do anything, it can't do anything, it's zero sized, has no data. And then we have this other variant, sum, that here in the far corner, hidden behind all the annotation, has an owned t that it contains, and something that looks very much like a tuple. And we did that too with the struct, same syntax. And that's it. So to make that a bit clearer, enum option t none sum t. And now we have our own option. It's kind of a stupid option that can't do all the optiony things yet. It's not nice to work with it, but you can. So let's try to use that. Let's build our own option and see how we can use that in practice. So we can have a function here that says maybe, and it gets an integer maybe. And it returns our stupid option now because we have our own type here. But we have to specify what kind of option that is, right? So what's inside of it. So now we have to decide for a type. And we kind of already have decided. Do we? Let's just say we have decided. It's the same thing as we put in. And then we can say if x is divisible by 2, then we have our option sum x, or else we have none. Maybe like this. And of course we want our option none, and not just that option that comes magically imported from our standard library. And that's interesting because now, we talk a bit about how to import stuff. Because I say, this none here, not this one, is kind of in our namespace. It's there. but it's actually the standard library options none or some. And we just have to know it's there for convenience, essentially. And that's part of the standard library prelude. So if you want to know what's in there, you can check the prelude. It's exactly that. We should be able to do that here. So if we use std prelude, I should be able to jump there. And now I can see what kind of stuff is in here. It's a bit hidden because of all these star imports, right? But somewhere in there is going to be my option and my variants of that option.
Okay, so this is just stuff that Rust gives you by default because it's used so often, I guess, or it's just easier than.
Yes. And I don't know if you remember, but once we ran this expand, let's see if I can hover over the right thing to get that suggestion again. Here, show the result of macro expand, cargo expand. And you will see that it actually adds that for us, right? So here we get the prelude. This is what we get. And we can just do this ourselves as well. We can also disable the prelude, for example. We can disable standard library. I mean, this is Rust, right? We can go to embedded devices which don't have a standard library, which don't have heap allocation. You just directly interact with memory, all no problem. So yes, this is actually happening here. But usually you don't see it and you don't have to. All right, but if I wanted to do this kind of stuff with my own option, or my own enum for that matter, because you can have your own, right? Instead of having true or false flags everywhere, you can just have an opt or an enum that spells out the possible variants that you see in your program, which helps with the readability. I do that a lot, by the way. And in order to do that, we can use this use statement here. So I can say use option asterisk. So all the variants that are in here, please bring them into my namespace. And that might now, oh yeah. So now we dig into module system unexpectedly. We just touch the surface, we just scratch the surface there. This says, please get the option from this module here, because the normal resolution for this kind of use case would be getting the option that is already, yeah, I don't know actually. Probably it tries to get some other option then, I don't know. Ambiguous, because there's the standard library option also there. It's in my namespace already, right? So it definitely is ambiguous now. It's either the standard library one or it's this one. So now I say, hey, it's this one here. And now I can do this. I just shadowed the standard library stuff. And you see it's not red. So now this sum and none refers to these two. And IntelliJ knows that as well. See the highlighting there?
Yeah.
And that's why. And if I wouldn't do that, it would now jump to the standard library. Makes sense, but I'm just saying this kind of magical stuff with the names of variants of some option being visible in your namespace or in your function, you can have that too. And for me, if I don't have a module that needs these variants everywhere, I just import the variants where I want to use them so they don't pollute the namespace, which just can be surprising. It's not a problem because it's all strongly typed, right? It's not a weird thing that then crashes at runtime or so, but it can be surprising and annoying. So I just keep the scope of these names that I import small usually. Yeah, but that's the syntax.
It's also easier to, I guess, pull the code apart later if you need to.
Yes.
Everything is then contained.
Yes, that is true. Very nice, very nice. How do you call that? Yeah, very nice thought there. And I can only second that. That's totally true. This also means that probably, unless the type is in the signature, you would go and then just use all the extra stuff that you need right here from other crates and so on. You can do that, even though it's less common. to do that. But yeah, it would make moving that one somewhere else to some other module particularly easy because all the types that you need are actually self-contained in here. But that I personally don't do. I just move things around and then re-import stuff using IntelliJ's import function there. It's pretty easy. Okay, so now we have our own custom option, and we can use maybe to do something. Maybe to. Let's see if that works. So now we can match on it. So if it's our, very uncomfortable here, inconvenient. If it's something, maybe is, it's definitely X. Otherwise, so now, by the way, you see that here, right? You see it's unhappy because we didn't cover a pattern. We didn't cover a variant here. So matches, they must be exhaustive. You can't just forget to handle something, which can be super powerful. And something
that does seem very nice, yeah. So enums and matches go together well.
Yes, very well. But also tuples and vectors, and yeah, you can do a lot with match. Match is very, very powerful and definitely helps you to write better programs. It's nothing. So probably let's see what we see here. If we execute this, it compiles. That was the wrong one. Run options and result. It's 2. Okay, we got that. And now let's put 1 there. And now it's nothing. And of course you could do that with Boolean flex and so on, right? But now your Boolean carries information, essentially. This is what options are.
It's interesting because I was thinking on how you would use that value because it's wrapped in something, right? It is wrapped in this enum variant.
Yes.
And okay, so match is the way to extract it then. You can kind of get to the inner value by using the match.
Yeah, that's correct. Once again, thanks for highlighting this so well, because that's exactly what match allows you to do, and only match. Because otherwise you wouldn't know what it is, essentially. And of course you could add more functions to that custom option. You can implement just about anything. Let's impl for any option over any t. By the way, this implies that you can also impl special stuff just for U32, right? So now only for options that carry U32, I have special U32 stuff, right? You can just generically implement this because this is how that usually works. So let's say I would like to have a function that does this, that just gives me the value because I want to do something with the value, and just that, give me the value. And we call that unwrap, and it's consuming the option itself. So after that, the option does not exist anymore, and out comes a t. Oh yeah, sorry, syntax. We have to declare the t, and then we can put it into the type accordingly. And now we do the same thing. We match on self, and if we are an option, I think it's really inconvenient to have the same name here. If you would rename it our option, it would be easier. Let's do this. Our option. I don't have to do this anymore. I can just do our option sum. So now some value v, and I return v, and now it gets interesting. Our option none. What do we do now? Because we just said we will always return a t, but we don't always have a t. Do we make a t up? Do we?
That seems like a good idea.
Right. You always get something. And maybe that's something we want, so that we don't have to make it up. Let's say unwrap or. So either you have something or we have something else that goes in that place. So here we return other. That seems to work. Yeah,
Nice.
that's nice. So that seems useful. Let's go back again to this one where we only have what we have. I mean, there's one way to deal with this that doesn't include setting something up or making something up, which is to stop the program. Like we can just panic and say unwrapped, try to unwrap empty option, not good. And that's that. Let's try the new cool things here. Okay, so maybe 2. Unwrap. And there we just print this, huh? Let's print this. Okay, that's 2. And now let's go with 1. And we just panicked our program. Try to unwrap empty options. It doesn't like it. And we can even click here. And, okay, let's run this again. And click here. So it at least tells us which function was panicking. And now we see, yeah, it's probably entering this branch. Yeah, and you guessed it. We're now writing our own option here. I mean, literally, our option is our own option, which just is a cheap copy of the option that's already coming in with the standard library. And this is just to show that everything that the actual option provides is just that. It's not magical at all. It's just some match statements and some functions and sometimes custom implementation depending on the type that is inside. And that is that. Let's rewrite this to be the standard library option, and we are done. And now you see it still works. Like unwrap is still a function because it's actually a thing, right? Option unwrap, which says give me what's in there, or panic if nothing is in there. And the same thing happens.
Just make that up.
Yeah, I used that before. On a none value. Yeah, good. I mean, same thing like before. Okay. And I think that this is the point to hammer home here. These things are super useful. And usually you don't have to match on them because there is some useful little function on it that you probably just have to know to save a lot of time. Because you save a lot of writing of match statement. Okay. So what about having something that doesn't crash the program? Unwrap or default. And now it prints 0 because the default of U32 is 0. And if there's nothing in there, we get the default. Look how that's implemented. Looks very similar to what we did before, but it says default, which is a trait. And because of type inference, Rust knows that you want a T. So you could also have written T here. Same thing.
Oh, I see. Okay.
And that works because we said that T must implement default. And you see that's a custom input block here. So for all T's that implement default, create that function.
That does make sense, I think.
Okay, let's put it to the test. Let's have another foo. And we know structs can't do anything. They're really useless. And if you put foo in here and try the same thing, what happens? Ah, sorry. Let's generalize this. Now we get into generics, but I guess it's hard to get around that. And it's so easy to use too, like for these simple cases. Oh, right. I don't have numbers anymore. Fair enough. Let's see if I can real quickly make that happen. Yeah, okay, I wanted to add some random number generator, but I guess we can do the same with time. So let's do that. std time, wait, Unix epoch. So how many seconds elapsed since the Unix epoch, I can ask. So I just say, so that's 1970 sometime, huh? So I just do this. I unwrap because we do get a result here, which we now just skip over, but unwrap means give me the good thing, like with the option. And now I ask it to give me seconds here. Whenever we have a second amount of seconds divisible by 2, we get some, otherwise we get none. Okay, so that's my workaround. So we get some different results from time to time. But it's still red, because unwrap or default exists for enum foo, but its trait bounds were not satisfied. Because we need foo default. Foo, there is no default foo here. See? And this just shows you how that constraint works on type T. And the compiler message actually nicely tells you what the problem is, because foo is default is not implemented for foo. So if you wanted to implement default for foo, we could. Yeah, IntelliJ, right? Like all this code generation stuff, you shouldn't write that yourself. And now I just return a foo here. And now look at this. Now look at this. IntelliJ, come.
Whenever you're ready.
Wake up. Let's try that again. Okay. I think it did something. So now it wants to display something, right? Now foo can't be displayed. What's easier is to use this kind of formatting syntax, formatting code, to say I want a debug print of that foo. And it doesn't implement that either. But fortunately, we can just derive debug, and it will automatically make foo debug printable. And I also think that default can be derived automatically, because it's such a simple struct. So now everything seems to be green. And now we get foo, we get foo, we get foo. Ah, yeah, right. Foo or foo, right? So whatever it is, it's always the same. There's no way to differentiate that. Maybe we make it foo42. Okay, and try again. So now the default is foo0. So you see, because what's in there implements default, it can implement default for the structure as well. Same with copy. And we seem to be quite unlucky here. Okay, there was the 42. It's interesting. There seems to be some sort of bias towards 0 here, but our sample size also isn't, with our randomness, isn't particularly good. Remember PlayStation 3, the random number generator that always returned, I think maybe even 42 or something, always static number, which allowed people to easily hack this?
Really? Wow,
Yeah,
no, don't know.
Really, PlayStation 3, that was for sure. It's so ridiculous, right? Like, oh my god. I think there wasn't even a to-do that says make this right, but maybe there was. So now we have something that is better than was in the PlayStation, I think. They could have just used the time. Anyway. That would probably be harder to figure out. Okay. So originally we came here to have a look at what options can do. Something I find particularly interesting, and I think that's where we have to also close the session, is that it's easy to get from a Boolean to raise or to lift a Boolean into an option. Think about it like this. So there's some flag, and if it's set, we want to, use some value in the program. But if it's not set, we don't want to have that value. So that can be represented by an option or a flag plus the value. So let's have both. So in theory, if you want to pass that along, let's have a function that says do it, and it uses foo. Let's just use foo because we have foo. So it has this value foo and our flag. And now we have to at all times say, okay, if we have a flag, then do something with value. Let's just drop it. So we actually do something with it. And otherwise do something else, or don't do anything. That's all cool. But now we have these two separated, right? And that makes it easier to make mistakes. Like, why can't we have the state or the type system help us with that? And that's where the option comes in. So you want to raise this flag into an option so that we can say this. We have an option of foo, an option of foo, and no flag at all. And now if we have some value in here, we can use it. And now because it's an option and you have to match on it either with such an if-let statement or with a match statement, you can't possibly get it wrong anymore. You can't misuse it. You can't use value if you should not use it because you didn't check the flag, because you simply can't get it wrong anymore. The type system prevents
you have to get around the option, basically. You have to make
Yes.
your way into it.
You have to make your way into it.
Yeah.
Again, wonderfully said. You have to somehow get into the optional land. And a nice way to do this, let's actually make this call, is to say, okay, we have the flag, and then the value should be, you just make something up here, that's fine, foo32. And look at this. Now I just lift my flag to become an optional. So this says if flag is true, then put this value into an option. So you see the compiler is happy and does compile and run. And that's so powerful. That really makes for super awesome code. And like all these things, they compose super neatly. And once you have your set of maybe 20 of these little functions, you're able to write more complicated code than has to be, because sometimes you just want to match on stuff. But there are the times when really this kind of changing comes in very handy and is very readable too. And I think that's one of these cases when you definitely want to know how to raise a Boolean. Yeah.
That does seem very, very useful. But the downside is, of course, you need to memorize or know all these functions, right? All these kind of transitions and everything in between.
Yes.
But I guess you'll get there.
Yeah, you will get there. It's okay to start with if-let and match everywhere, and then you'll be sick of it because you type so much and your fingers bleed. And once they bleed just enough, then you will learn. You will have motivation to learn these functions. I think that's how that works. That's how it worked for me, I guess. Because sometimes, you just have to learn them. By the way, this then, it's relatively new. It came with Rust 1.5. And it's so cool to have functions on a bool, right? Inbuilt bool. You don't see that a lot in programming languages. At least I didn't. For me, this was new. but it makes perfect sense. And I can imagine so many more interesting functions on Bool pop up over time. Because sometimes it just then doesn't compose perfectly, let's say. But it's good enough for many cases. Yeah, I think that could be our session for today. And I take your silence as you agree. And
I have a lot to take in. That was quite much, but I like it.
And we will do so much
Thank you very
more
much.
in the next sessions on Monday, I suppose. And I'll see you then. Thanks for watching. Bye-bye.
Bye-bye.